Hi guys, I feel like this is take 3 on this video. Been a rough week with this particular lesson. It's a longer one, which created some problems in uploading, so I just came back to BB Collaborate, fewer restrictions here, and then I think I can link this in the content section. So let's hope this works, fingers crossed. Also, to compensate for this being late, I'm going to go ahead and extend the deadline on test 2. Now that said, I kind of push test 2 up originally so that you'd have a grade before you need to decide whether you're going to withdraw from the class. It's up to you if you want to take this test before the withdrawal date. If you decide to wait, that's fine. I also want to say that to me, test 2 is the hardest, so keep that in mind. 3 and 4 should be a little bit easier than this test. This test just has so much of the math and graphing on it that might make it difficult. But all right, so here we go. So production and cost. One of the things to understand is that as we get into these cost curves, which is a lot of what we're doing, that our cost curves are essentially related or a function to our production curves. And our production curves are all based on this notion of diminishing returns, that production faces diminishing returns. So diminishing returns to production. What does that mean? All right, so basically what that means is that as we add additional inputs, production is increasing, but at a decreasing rate. All right, so it's, and I should say holding all else constant. So for example, if we hold all else constant, for example, equipment, adding additional workers will increase productivity, but at a decreasing rate. Okay, or conversely, if we hold workers constant, but add additional machinery, or what economists refer to as capital, physical capital, production will increase, but at a decreasing rate. Right? If you change both workers and machinery at the same time, that is a kind of a different phenomenon. That's a different term. So with diminishing returns, you're holding everything constant and just changing one of the factors of production. Now this pattern doesn't exist in the very beginning, all right? So let's see if I can do this here. So let's say we are going to have labor. So this is going to be our number of workers. And then we're going to have our output, which in Econ often we're going to abbreviate. Let me actually type the word output. We're going to abbreviate Q. So if I've got no workers, right, 0 workers, then let's just assume that I am not going to produce any output. Let's say I hire my first worker. All right, now my first worker by themselves might be able to create 10 units, okay? So whatever it is in a day, this worker can create 10. Now, in the beginning, right, diminishing returns actually doesn't hold. In the beginning, we actually can have increasing returns due to specialization. So I always like to use kind of the classic, like, Chipotle counter example. Chipotle, Subway, Moe's, any of these folks work by it, right? So imagine you walked into Chipotle and there's only one person. So it's one person asking you, you know, do you want the burrito or the tacos, the salad, right? So they're getting it started. Then they have to walk over and they put in your rice and beans and protein, and then they're sliding down what veggies and other toppings do you want. Then they're coming all the way down to the register. They're probably taking off those gloves, right? They're tapping in, they're taking your payment, giving you your receipt, and then they've got to walk all the way back down to the beginning again for the next customer. And what do they have to do? They have to put on those gloves again, right? And if you've ever put on those little restaurant or medical latex gloves, right, it can take a minute. So there's a lot of inefficiency in that. By getting a second person on that counter such that you have 2 workers, you can have one person that just leaves their gloves on, right, the entire time and does all the food, and a second person that does that takes payment. And because you've got those 2 people that are specializing, right, we saw in comparative advantage how important specializing is. Because you've got 2 people specializing, perhaps total production goes up to 22. Right, so then you're like, ooh, this is great. Let me add a third person. And very often that's what you see kind of working the front of those Chipotle bars, right, is you got one doing the first section all the way down to your proteins, and the second one doing the veggies and toppings, and the third person that's taking care of the card, right? So maybe you've got 3 people, and your total production goes to, let's just say, 30. Right, so you're getting 30 burritos made an hour, whatever it might be. Let's say you have this idea, ooh, this is nice, my production is increasing, right? So you decide to add a 4th worker. Well, now you kind of got your folks like shoulder to shoulder, right? They're bumping into a little, they're bumping into each other. Maybe production is still going up, but there's some kind of added inefficiencies. So production might go up to 36, right? Still, you're just convinced, look, production goes up every time I add another worker, right? So you add that 5th worker, and production, in fact, might go up. Maybe you hit 40. So once again, you're like, woohoo, let's just keep adding workers. So we add a 6th worker. I don't know about you guys, but those counters aren't that long, right? You add a 6th worker, they're literally like 2 people reaching for a spoon, or maybe they start chatting, or maybe they start fighting. At some point, it's actually possible for your production to even go down because you've got too many people and they're just not working very efficiently. So this could be kind of a standard output model. It's actually much shorter. There should be an Excel file in content where I believe it goes up to 10 workers or 12 workers. You'll find the same pattern. But what I want to mention is what's referred to, let's draw another line here, as the marginal product of labor. Actually, I don't need another line. All right, so marginal product. When you hear the word marginal in economics, it means change. All right, so anytime you hear the word marginal, I need you to think of change, such that the marginal product of labor would be the change in the products produced as the result of an additional worker. All right, so that formula is going to equal the change in output divided by the change in labor. For us, that change in labor is always equal to 1, right? Every step is 1 worker. In the real world, it might not be. You might be using teams or groups of people, but it's the change in output divided by the change in labor. For us, change in labor is going to be 1, which basically means that the marginal product of labor is going to be this change in output divided by 1 each time, or just this change in output as we step down the graph. So what's my change from 0 to 1 workers? My change in output would be 10. All right, from 1 worker to 2, my change in output is 12. This is not diminishing returns yet. This would be increasing returns. So in the beginning, so for us it's between 0 and 2, in the beginning you can sometimes see increasing returns due to specialization, but those don't last. All right, so as I go from 2 to 3 workers, I'm going to change the color here just to note where it's changing. From 2 to 3 workers, right, my production only goes up by 8. And from 3 to 4 workers, it only goes up by 6. And from 4 to 5 workers, it's only going up by 4. And then, well, so let me actually focus on that first. So from after my 2nd worker, so this would basically be from my 2nd worker through my 5th worker, right? So after the 2nd, I should say, from hiring that 3rd worker. So from the 3rd worker through the 5th worker, I have diminishing returns. In a true production function, this would be the majority of your area that would fall into here. You know, I'm adding 8, then I'm only adding 6, then I'm only adding 4. My production is increasing, right? From 30 to 36 to 40. My production is increasing, but the rate of increase, the size of that change, is getting smaller and smaller. And yes, it is true that it is possible for that to even turn negative at some point. All right, so this is what we mean when we talk about diminishing returns to production. Now, if you were to graph what a marginal product of labor looks like, let's see if I can do this. All right, so if you were to graph marginal product of labor, so here's my axes. I'm going to put, it's a little bit different than normal, right? I'm going to actually put output on my horizontal. That's my output or my quantity. I'm going to put the number of workers on my horizontal axis. In the beginning, in the blue there, let's change to blue. In the beginning with the blue, right, I've got the increasing returns as they go from 0 workers to 1 worker to 2 workers, right? There's my max right here, so that would correspond to my 12 at 2 workers. And then, again, I'm graphing the marginal product of labor here. And then, where am I? I'm switching to red here. Then what happens is my line starts to fall, right? So it goes from that maximum of 12 down to 8. Oops, this is not drawn to scale, but you get the idea. Down to 6, down to 4, and yes, it can eventually turn negative. Okay, so thinking about this marginal product of labor, what does, just so you guys can see it, what does this look like if you were to graph total production? Basically what total production looks like, oops, not a straight line there. What does total production look like? You would start off at 0, and then you'd have something that's increasing but at a decreasing rate, right? And then in our case, in the numbers I gave, it can actually dip down negative. So this is what the total production would look like. So this is a graph of total production, again with number of workers and output. And then this one, though, the one that I care more about, is the marginal product of labor. Okay, all right, so that's the first graph. So understand that all of our cost curves are basically going to come from this fact that we have diminishing returns to labor across much of this production function. All right, so let's clear the screen here. And let's talk a little bit about our cost side, okay? Let me see. Let me pause recording for a second, and I'm going to actually pull up an Excel file and see if I can share that with you. Actually, I think the easiest thing is I'm going to stop this recording. I don't know if it'll let me start a new meeting. All right. We'll see. We'll see how this works.